Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. This is 3.6 day 2. This is all going to be review. I will try to go through this a little bit slowly so that you can catch exactly how to choose which form of factoring you need to be using. So we need to find all real and imaginary roots for the polynomials. Basically all that means is we need to solve. So problem number 1, we have 4 terms. There's a couple options when we have 4 terms. The first one would be grouping. We always want to try to group first. In order to see if we can group or not, we're going to look at just the numbers. Don't worry about the variables. The first number is 1, the second number is -4. There is no GCF between 1 and -4, so those would be the numbers that would be inside the parentheses once I group these. I need to see, is it possible for me to divide 2 and 4 in order to get 1 and 4? So can I divide anything, 2 by anything in order to get to 1? I could divide by 2, but that would lead me to have to divide 4 by 2, and that will not ever get me back to -4. So in this case, what I'm going to have to do is use synthetic division. So I need to make my list. The possibilities for 4 are 1 times 4 and 2 times 2. The front is just 1, so I only have to put each one of my terms for 4, or my factors of 4, over 1 in my list. So x will equal plus or minus, my smallest one is 1 over 1. My next smallest would be 2 over 1, and then finally 4 over 1. So those are my only options. Now I need to go ahead and use synthetic division. Since I'm going to use synthetic division, I need to use my coefficients. So 1, -4, 2, and 4. I'm going to use short track synthetic because I'm not sure exactly how many times I'm going to have to do synthetic division. If I use 1 first, I'm going to go ahead and drop my 1. 1 times 1 is 1. -4 would get me -3. -3 times 1 is -3, plus 2 would get me -1. -1 times 1 is -1, plus 4 would be +3, so that is not going to work. Now I go ahead and try -1. Drop my 1. 1 times -1 is -1. -1 minus 4 would be -5. -5 times -1 is +5. Plus 2 would be 7. 7 times -1 is -7. Plus 4 would be -3. And again, that will not work. So I can move on to +2. If I use +2, drop my 1. 1 times 2 is 2. Minus 4 would be -2. -2 times 2 is -4. -4 plus 2 is again -2. -2 times 2 is -4, plus 4 would be 0. That would be my remainder, so this should work. Remember, when I find the factor that works, I need to write it down as x and opposite this number. Then I need to use this line. Since my degree started out as x to the third, I would have x squared to start with, from 1 being my coefficient, then -2x from this coefficient, and then -2 from my last coefficient. All that would equal 0. Now I need to look at x squared minus 2x minus 2 to see if I can factor. Since there is no coefficient in front of x squared, all I have to worry about are the factors of -2. Is there anything that can multiply to -2 that would also add to -2? Well, the only things that multiply to 2 are 1 and 2. Those could never add to -2. So I'm going to have to use the quadratic formula for that to factor that term. However, x minus 2 I can just set equal to 0. Add 2, so x would equal 2, and that part would be done. Now I need to use the quadratic formula to solve my second polynomial. So x would equal the opposite of b, so 2 plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is -2. All of that would be over 2 times 1 because my a value is 1. Now I need to go ahead and simplify. So x equals 2 plus or minus the square root. Negative 2 squared would be 4. Negative 4 times negative 2 times 1 would be positive 8. Okay? All of that would be over 2 because 2 times 1 is 2. Continue simplifying. 2 plus or minus the square root of 12 over 2. I cannot take the square root of 12, so I need to go ahead and break up the square root of 12. So x would equal 2 plus or minus the square root of 4 and the square root of 3 all over 2. X would equal 2 plus or minus the square root of 4 is 2. I cannot do anything with the square root of 3. Now I have a GCF between 2 and 2 root 3. That would again be 2, so it would be 2 parenthesis 1 plus or minus root 3 all over 2. The 2's would cancel. So x would also equal 1 plus or minus the square root of 3. Okay? Hopefully you remember how to use the quadratic formula. If you do not, make sure you either come in and get some assistance, or you can go back and watch the video on the quadratic formula. It is just a formula. All you have to do is plug things in and work through it. Now, problem number 2. It only has 3 terms. So the hierarchy with 3 terms is I'm going to look for a GCF. There is no number in front of x to the 5th, so it will not be a number will not be included in my GCF. But I do have x's in all 3 terms, so my GCF would be x, which would leave me with x to the 4th plus 5x squared minus 24. All that would be equal to 0. X, I can do nothing else with x, but I can factor x to the 4th plus 5x squared minus 24. The terms of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So which one of those could possibly add up to 5? That would be 3 and 8. Since I need a positive 5, my 3 is what would be negative, so it would be x. Since I have an x to the 4th, my first term is always going to be x squared. I know my 3 needs to be negative, so it will be x squared minus 3 times x squared plus 8 equals 0. Now, I cannot factor the x squared minus 3 any further because 3 is not a perfect square. I cannot factor the x squared plus 8 any further because 8 is not a perfect square, and it is the sum of 2 numbers. So I need to set everything equal to 0. So x equals 0, x squared minus 3 equals 0, and x squared plus 8 equals 0. I'm going to work with the x squared minus 3 first, so I'll add 3. So x squared would equal 3. The square root of that would get me x equals plus or minus the square root of 3. I'm done there. Now the x squared plus 8. I need to subtract 8 from both sides. X squared would equal negative 8. Take the square root. So x would equal, I can break up the square root of negative 8 into the square root of 4, the square root of 2, and the square root of negative 1. So then my answer would be the square root of 4 is plus or minus 2. The square root of negative 1 is I. The square root of 2 would just stay the square root of 2. So I am done with that problem as well. Again, if you're having issues with square roots, there's a video on square roots, or you can come in and get some extra help on that as well. On to problem 3. Now, problem 3 is 4 terms. The first thing I want to try to do is group them. As you can see, there is a GCF between 2 and 2. It would be 2, right? So I could have 2, which would leave me with 1 and 1 inside my parentheses. What is the GCF between 8 and 8? That would be 8, which would again leave me with 1 and 1 inside my parentheses. So this would actually group fine. I'm going to split it right down the middle. What is the GCF between 2x to the 3rd and 2x squared? It's going to be 2x squared, which would leave me with x plus 1. What's the GCF between 8x and 8? It would be positive 8, which would leave me with x plus 1. In grouping, I'm going to go ahead and put my GCFs into a parenthesis by themselves, so 2x squared plus 8 times, since these parentheses are the same, I can go ahead and just write them down one time. All of this is going to be equal to 0, since I need to solve. Now 2x squared plus 8 does have a GCF. It would be 2, so that would leave me with x squared plus 4 times x plus 1. Now x squared plus 4. X squared is a perfect square. 4 is a perfect square, but since I have an addition sign there, I cannot take the difference of two squares, so I cannot factor that any further. What I'm going to go ahead and do then is set everything equal to 0. Well, 2 does not equal 0. X squared plus 4 would equal 0, and x plus 1 equals 0. X plus 1 is pretty easy. I just subtract 1. X squared plus 4. I need to subtract my 4. That would leave me with x squared is equal to negative 4. From there, I need to take the square root of x squared and the square root of negative 4. So x would equal plus or minus. Remember, whenever I have a negative, there's going to be an I involved. The square root of 4 is 2. So my answer is plus or minus 2i. Finally, number 4. I need to look. I have a subtraction sign. I only have two terms. So I'm going to look for the difference of two squares. I want to check out if 256 is a perfect square. So I would take the square root of 256. If you type that into your calculator, you will find out that it is 16. So the square root of 256 is 16. What is the square root of x to the fourth? The square root of x to the fourth would end up being x squared. So, since they are the difference of two squares, I can set up two sets of parentheses. The square root of x to the fourth goes in the beginning. 16 goes in the end. Now, what would I make my signs? They would be positive and negative. We've been talking about that for quite a while. X squared plus 16, though x squared is a perfect square and 16 is a perfect square, we cannot use the difference of two squares, so I'm going to leave that as x squared plus 16. However, in my second set of parentheses at the top here, x squared is a perfect square, 16 is a perfect square, and I have a subtraction sign, so again I can make two sets of parentheses. I'm going to put the square root of x squared in the beginning, the square root of 16 at the end, and I would have a positive and a negative. From here, I can no longer factor any of those three, so what I will do is set them all equal to 0. The x plus 4 is pretty simple. I would subtract 4, so x equals negative 4. The x minus 4 is pretty simple. Add 4 to both sides, so x would equal 4. Now, x squared plus 16. Here I would have to subtract 16. So x squared is equal to negative 16. I would have to take the square root. So x would equal. 16 is a perfect square, so it would be plus or minus 4. Remember that if there's ever a negative under the square root, I'll have an I involved. And I am done. So in this video, we went over how to do synthetic division again. We found our list, did synthetic division. Once we had that completed, where we had 0 as our remainder, we went ahead and made our terms. Because the one term could not be factored, I had to use the quadratic formula. In problem number 2, I went ahead and took a GCF. I was able to factor my trinomial into two binomials, and then I had to use my square root principles in order to figure out the answer to those problems. In problem 3, we were able to group it, and again I had to use some square root principles. In problem 4, it was the difference of two squares. I was able to do the difference of two squares again, but in one of my terms I had to use some square root principles. So if you can remember your square root principles, how to use synthetic, how to use quadratic formula, and how to group, you're going to do very well on this worksheet. If not, please come in, get some help on this stuff. Let me help you review it, and we will get you to the point where you will be fine. Otherwise, thank you very much for watching the video, and have a great day.